So in question 3, we have a sector AOB of a circle with center O and radius R. We have that the angle AOB is theta radians. So our theta here is in radians, and that the area of the sector AOB is 11 centimeters squared. We're also given that the perimeter of the sector is 4 times the length of the arc AB, and we want to find the exact value of R. So if we extract some of this information, we're told that the perimeter of sector is equal to 4 times the arc length AB, and we're told that the area of the sector AOB is in fact 11 centimeters squared. So let's label the arc length first. So that's L. And let's maybe use L and R to write an expression for the perimeter of the sector using the arc length. So the perimeter of the sector is just going to be the length of the 2 radii plus this arc length. Okay, so recall the definition of your perimeter, and if it helps, think of having a piece of string and you're bordering the shape with your piece of string. So if I do that, what is the final length of my piece of string bordering this sector? It's going to be the total length of R plus L. So the perimeter of sector is R plus L, which is just 2R plus L. And our arc length, so that's length L, is equal to R theta. So have a look at your equations and your formulas for sectors. So you should see arc length L is equal to R theta for theta in radians. And then we can kind of rewrite this statement here using what we've written for the perimeter of the sector and the arc length. So we're then rewriting what we have starred there. So the perimeter of the sector, well, we just found that that's 2R plus L. So 2R plus L is equal to 4 lots of the arc length of AB, which we've just found as R theta. So now we have this equation here. So let's call that equation 1. And then we're told as well that the area of the sector is 11 centimeters squared. Now, what is our formula for the area of the sector? So our area of sector equation is equal to half R squared theta. Maybe I'll start writing it down here where the lines are. So area of sector equals a half R squared theta, which is equal to 11. So half R squared theta equals 11. That's our equation 2 here. So let me rewrite equation 1 down here as well. 2R plus L equals 4R theta. That's equation 1. And we can, I actually didn't replace L on the left-hand side, which I absolutely can because that's the arc length. And we've just written down that the arc length is in fact R theta. So we can write 2R plus L, where L is R theta as well. So I get 4R theta there. Now, as you can see, if I collect like terms, I can simplify this a little bit because I can bring this r theta onto the right by doing minus r theta minus r theta. So we get 2r equals 3r theta. And then I can simplify that further because we can see that the r's cancel. Let me write it like this. The r's cancel on both sides. And we get 2 over 3 equal to theta. Now, we can use this value for theta and plug it in to equation 2. So we can substitute this value for theta into equation 2, which I've written down here. And remember, that comes from our area of the sector because we were told it's 11 centimeters squared. So we just equated it to our formula for the area. So now let's plug in this value of theta. So we can rewrite this as half r squared. Theta is 2 over 3 equals 11. And remember what we're trying to do. We're trying to find an exact value of r. So now let's solve for r. We just need to simplify a little bit here. So half times 2/3, that's going to be 1/3 r squared equals 11. Let's multiply both sides by 3 to get rid of our fraction of 1/3 on the left. So we get r squared equals 33. And so r will equal the square root of 33. And so now we found the exact value of r.